All right, this is group 5. We did a producing power with Rankine-style and reheat. I am Andrew Wisner.
I'm Morgan Browning.
And I'm Trevor Brackett.
For our objective for our project, it was to utilize Aspen to simulate a steam working fluid Rankine cycle with reheat and to estimate the amount of power it can generate. And then after we determined the amount of power generated, we determined cost of equipment, maintenance, and employees, and went to Excel to perform an economic analysis to find the payback period of the project. And we determined if using this method to generate power is efficient as well, if the project is worth investing in.
The overview of the project, we made an Aspen simulation and it returned a potential to produce 1,280,092 kilowatt hours per day if it was running for 12 hours a day. And we looked up that we found out the price of 1 kilowatt hour in Florida is an average of 12 cents, which means that with yearly expenses, assuming we run about 220 days out of the year, our net profit is about 34 million. And comparing that to the initial investment, we figured that the entire project would be paid off within 15 years. This is our Aspen simulation. You can see the flow sheet on the left. We did a Rankine cycle with reheat. So we have steam going into the boiler, which is heating it up to 600 degrees Celsius. And then it's going into turbine 1, where it's going through and producing power. And we put it through the reheat to get it back up to 600 degrees Celsius. So we can run it through the second turbine to get even more power. And then it's condensed down back to a liquid and some heat's removed through the condenser. And we pump it back up to 10 megapascals and back into the boiler for the cycle to continue. Analyzing the cycle, we found that by using 250,000 kilograms of steam per hour, which we found through research paper was about a typical number for a power plant, turbine 1 and 2 produced a total of about 100,000 kilowatts of work. And since the pump requires 190 kilowatts of work, and the net work we got was still about 100,000, and the boiler and reheater required about 200,000 kilowatts of energy, and 160,000 kilowatts of that energy can come back from the condenser, which so once we reach steady state, we'll only really need to supply about 100,000 kilowatts for every hour. And in order to provide the energy to heat the steam, we decided we were going to use coal. So we looked at the different heating values and costs of coal and found that we found the coal that was the most effective for its heating value, which it ended up only being about 8 cents per second, which was pretty cheap compared to, it only came out to about $4,000 per day for the cost of coal when we make about $30 million every day. And running at 12 hours a day, we produced about 1.2 million kilowatt hours per day to sell.
For the Excel analysis, we use present worth to determine the payback period, taking into account compounded interest. We assumed that the interest rate was going to be 6%. Looking at all the parts and stuff that we needed, we assumed that the approximate cost of machinery and construction would be around 323 million. And then, like we said before, we assumed that the price would be 12 cents per kilowatt hour. And the yearly expenses consisted of the cost of coal and the wages for a 10-person crew. We figured once we got it up and running, it would only take a small amount of people to keep running and do the maintenance. And we already subtracted that from the yearly cash flow. The yearly net income was found to be just over 34 million after the yearly expenses were deducted. And looking at this and taking it away from the initial investment, we found that the expenses were paid off just after 15 years. The numerical methods that we used to do this project was creating an Aspen simulation using the Pang-Robinson method. We performed the economic analysis on the project by finding the present worth with the compounded interest formula. And using that, we created a cash flow table showing us the discounted cash flow rate. And we turned that into a graph and used the equation from the graph to figure out that the payback period was around 15 years. The new concepts and tools that we used was our knowledge gained from the examples with the lectures and homework assignments. We were able to use Aspen and cash flow table in Excel. I know before this class I had no idea anything about that. However, this was our first time creating an Aspen simulation of a Rankine cycle with reheat, which generates power. So that was definitely a challenge in the beginning. It was our first time analyzing equipment costs, startup costs, and power output of a Rankine cycle in Aspen, and analyzing the economics of the project. The reheat was a new concept that allowed more power to be generated without overheating the system and damaging the equipment. So we kept the maintenance fees down while being as productive and efficient as possible.
We have concluded that power plants are very big investments, and based on the results that we found from our particular project and the economic analysis of it, that the Rankine cycle with reheat that we designed in Aspen will have a relatively short payback period. And based on that fact, we have concluded that this project is worth investing in. What we have learned throughout doing this project, we learned how to simulate a Rankine cycle in Aspen and to calculate the payback period for real power cycle processes, which we've never done before or have any experience in. And we also accounted for work crew and material power requirements. Basically, we went more in depth with our project.
And these are our references. The first one is what we used to help create the Aspen cycle and figure out what was the normal amount of steam to put through a power plant per hour. The second reference was used to analyze the coal and figure out all the heating values and the costs. Number 2 was to figure out the costs, and number 3 was to figure out all the heating values. And then number 4 was to figure out how much we could actually sell the electricity for in Florida. And yeah, that concludes our project. Thank you very much.